Okay, hello everyone. This is a continuation of module 14. This is video number 3 out of a possible 4 videos. Maybe just a summary of what we've done so far so that don't want to end a copy. Let me see. Right. So we are discussing module 14, which is the transport layer. And so far, we had introduced it as a layer which is responsible for logical communication. Logical communication between two devices. I gave an example of it being a connection without that physical connection, a connection between two devices without the physical medium. And I put reference to the physical layer, which is also a connection between two devices, but more in a physical manner where we actually have a medium between them. So layer 4 is almost the same thing. There is a connection between two devices, but it is a logical connection instead of a physical one. We introduced the transport layer as well as responsible for a couple of things, segmentation, where data needs to be broken down, divided into smaller segments, which comes with some advantages in handling bandwidth, in handling errors as well. So data, instead of being sent is huge chunks of data. It is broken down, divided so that it is transmitted in smaller sizes. So the transport layer is responsible for that segmentation. Then there's also sequencing to add to that, which will lead us to TCP, which is a reliable, protocol. Without sequencing, we have another protocol which is UDP, less overhead, much faster, used for applications which can tolerate some data loss. Right. We also introduced, let me see, applications that uses TCP, applications that uses UDP. What are those applications? In this one, TCP was very easy. It focused mostly on reliability, meaning there were sequence numbers, there were acknowledgement numbers, which were being used to provide, to offer reliability, during data transmission. Then on the other end, we have UDP, which comes with less overhead, more speed of transmission, however, not so reliable. And I think with that, that basically summarizes what we've been talking so far in videos 1 and 2. Now continuing, uh, we last left off on the socket pairs, where we introduced the socket pair as a combination of the port and the IP address. So you can see from diagram ready pan up, we have two applications basically. We have FTP application and web application, which are being in use between the communication of the source and the destination. Let's just say a client and the server. These ones, right? The socket pair is just a combination of the IP address and the port number, which is used to distinguish multiple processes, basically. So with layer 3, we distinguish the destination using the IP address. That's how we separate Kutitulo and Rakunani, device A, device B, device C. With layer 4, we use the port numbers to distinguish between applications. So a combination of those two, I think, gives a better picture of distinguishing which device, which application is the destination for a given packet during communication. Now, you see uh, in exams, questioning, you see something like this. the representation of the pair, representation of the socket pair. Representation is as simple as this. You can see the IP address. Let me see. I'm going to use this example here. So we have the source for FTP of FTP connection. The source and the source, they go together. So we have 192.168.1.5 with, okay, just a minute. I want to make sure I'm separating it the right way with this 1305. So this is the source. Then we have for the destination 192.168.1.7.21 destination. So these two make what we call a socket pair. These two make what we call a socket pair, with this one being the client, the source. This is the client pair. This is the client socket. Then this one is the server socket. So if you are being asked, typical exam questions, they ask you identify the socket pair for a given connection. You just have to identify the source IP and the source port number, the destination IP and the destination port number. Those two making a socket pair. So you could do the same with the web application. The socket pair, we have 192.168.1.5, 192.168.1.7. The source is 1099. The destination is 80. So you see, I think that is what we're going to be discussing soon after this slide. You see these port numbers, they represent certain applications, especially the destination. We have what we know as well-known ports. 21 for FTP, 80 for HTTP. Those are well-known ports. So you see that the destination ports will most probably be well-known ports in the source. These source ports, these are just randomly generated ports, but the destination will specify the application which is being used. Right. Port number groups. So we have a range of port numbers that we use from 0 to 65. Let me see. 0 to 65535. Those are all the port numbers that are in use. Port numbers are assigned by IANA, which is also responsible for assigning IP addresses. This organization right here is the one which is also responsible for assigning IP addresses. IANA is responsible for assigning these port numbers, which are 16 bits, 16-bit numbers. We have what we call the well-known ports, 0 to 1023. These are reserved for the common or popular services and applications such as web browsers, email clients, remote access clients. Defined web ports for common server applications enable clients to easily identify the associated services required. So you realize with well-known ports, this is where you have common protocols. Let's start with protocols. It can either be protocols or applications. Starting with protocols, all the protocols that are well known: DNS, DHCP, HTTP. You can name them, all of them. SSH, Telnet, FTP, SNMP, SMTP. All those well-known protocols, they have well-known ports from this range. I think DNS is 53, DHCP should be 67. Not so sure. HTTP 80. I'm sure of this one. This should be 23 or 22. Between these two, 22 and then FTP 20 and 21. Those are well-known ports. So if we start off from excuse me. So if we start off from understanding module 3 protocols and modules, Takati should know every layer and its protocols. Most importantly, I think application layer and the protocols around. Wazivama protocols actually, you also need to know their port numbers because they're well known. Their port numbers you need to know. Typical questions, we just list a number of well-known protocols. Almost the typical port number actually. So all my protocols are my application layer, which are well-known, which are common. They have well-known port numbers, and you need to know them. Right. Then we have my registered ports. These ports, these processes are primarily individual applications that a user is chosen to install rather than the common applications that would receive a well-known port number. So with registered ports, it allows us to have greater flexibility because it provides us with a range of applications which do not have well-known ports. As a user, you just need to register. So you have your own application, but it is not amongst this range of well-known ports. You have your own application. You also want to assign it to a port number. Then you come here, this range, that's where you register. You can register your application. I don't know if you can come up with a protocol. No, it's a standard organization. So it's only protocols for this one. It's only applications, I mean. So you can come up, okay, you can have your own application. Then you can register it with IANA so that it has a port number. Example, do appear by Cisco registered 1812 to its Radius server authentication process. So 1812, it is known as a port number, destination port number, radius, which is an authentication service used by Cisco. So it's either an organization, individuals can register their own applications, services via IANA so that they can have registered ports. Right. Then we have lastly private dynamic ports. These are also known as ephemeral. The client's OS usually assign port numbers dynamically when a connection to a service is initiated. The dynamic port is then used to identify the client application during communication. Right, with private ports, these ones I usually define them as temporary ports. So every time there is communication, the source port is usually a temporary port. The source port is just generated automatically, usually a temporary port, so that you can have communication. What is important is the destination port, because this one is very much linked to the service of the application of the protocol. So if I want to communicate via DNS, if I'm using DNS, which one do I know for effect? HTTP. If I'm communicating via HTTP, this HTTP, you see definitely my destination port will be port number 8. But my source port from the client side, my source port will be a randomly generated port, which is usually from this range. Remember, private or dynamic ports, because it is just a temporary port. Once communication appears, we want to do another session, we generate another random port number, we communicate just like that. So these are the port groups that we have well known, registered in private. What's important, the I am a well-known, because typical exam questions, anyway, you are just given protocol opens on which port number do they use, because they are well-known ports. It's a random or dynamically generated port number. You must know them. So from the application layer, the protocols that are in the application layer, what are their functions? What roles do they play in networking? Yes, and ISAPA, you should know what roles they play in networking. Then, since we've added another one, port numbers, you should know what my port numbers for the respective protocols in the app. Right, I've already a list. Right, these are well-known port numbers. 20, 21, 22, TCP, SSHS, Telnet, DNS is here. DNS is 53 hours, correct? DHCP 67, correct as well. You should know these well-known port numbers. I think these ones, from experience, I've seen these ones in the exam. These ones definitely 25, nah. This one, 67. Right, DHCP. Some protocols, they have two port numbers. So you see this one, for example, this one. This source is not automatically generated because it's a well-known port number. But for every other protocol or application, which is not this one, then you have the source port being automatically generated. This one is also very uh it's not like every other protocol which is one port number. This one, it is two. One port number is for data, and for the other one is for control traffic. Control traffic, managing traffic which is used to uh manage the file transfer basically. Then the data is the actual data that you are transferring. Excuse me. Right. HTTP, this one is a must know as well. HTTP, probably this one, SNMP. HTTPS, not so much. So every other protocol that I've highlighted there, you must know. Right. The nested command. Unexplained TCP connections can pose a major security threat. NetStat is an important tool to verify connections. Right. NetStat is basically a tool which is used in networking for troubleshooting and monitoring. This is how it works. I think let me demonstrate it up on my PC. Let me see. So it just displays some useful information. Let's start with NetStat. Isn't anything else? NetStat. All right, voila. So it displays, as you can see, protocol, source address, destination, the foreign address, then the state of TCP connections. Every connection, active or not active on the PC, so I can see are easily recognizable. But here, WhatsApp here, because I've opened WhatsApp. Then HTTPS is probably my connections akavhurwa pa browser rangu yeZoom apa inenge iri papa. Let me see kuti yeZoom. I'm not so sure the foreign address yeZoom ichi, but because I'm open, ndine Zoom yakavhurwa, I could see using NetStat kuti Zoom iri papa. So why is useful? It can let you see what connections are basically running on your device. Kana pane ma-connections mamwe ari behind the scenes for security reasons, pamwe ari siri kufana hunge ari behind the scenes, hackers and stuff like that. You can basically see using the NetStat command. Right. Ine variations anayo. You can have you need to know why. You can have NetStat, I don't know of NetStat A. This one displays only my active net start A neka dash A. It only displays only my active connections. This one it displays all my connections, active and not active. Right, this one active, only active. Then there is the other one in a way, display an a TCP should be T, not recognize T as Kubuda. U net. Okay, there's a command this net start. Net start T. Right. This one, nobody tell me connection is a TCP only. Right. There's other one, nobody say UDP. These are very useful commands. I remember there was an interview, one of the first interviews, and I read that this command was what's your understanding of the net start command? Very useful. All right. There's another one in Ubritsa. ST. Right. I think Doma commands are share. E displays Ethernet statistics. F fully qualified domain names. N numbers and port numbers in numerical form. Let's try N. Play around with this command. So this one, instead of having my domain names pan up, but foreign address up. Like this one, I'm gonna WhatsApp chat GP, chat DH, what. That's probably a domain name in Rebel, right? Instead of having that, this one in N, there's my addresses and only my addresses, but it's almost the same type of information in Gerubuda. So NetStart valuable tool used to see my connections that are running on the system currently, the app, active or not active connections that are there. Very useful tool, this one. NetStart. All right. Server process. Each application process running on a server is configured to use a port number. We've gone through that. An individual server cannot have two services assigned to the same port number, okay, within the same transport layer service. An active server application assigned to a specific port is considered open, which means that the transport layer accepts and processes segments addressed to that port. Any incoming client request addressed to the correct socket is accepted and the data is passed to the server application. What do we have here? Okay. I think what I can take out of this, we have, let's go through the diagram. I think it best explains what is on this slide. We have clients, two clients communicating with the server. So we have two clients communicating with the server. Right here, you can see our source port and destination ports. Oh, yeah. Right. This is for the HTTP request. Like I had mentioned, the destination port zvofambidzana the application yauri kushandisa. Kana uri kushandisa HTTP, the destination port shows up as 80. Then this one, source port, randomly generated port number, a temporary port number. Then for SMTP, the destination is 25, which is the same as the port number of the application in use. Then this one, source port automatically generated as well. Then kana information yakubva from the server. So this is perspective a client. Kana information yakubva server, the source port now becomes 80, then the destination becomes this one. The temporary port rengerambo it was dynamically assigned to the port. Then kana communication appear. Zero port is now available. ranga rimbori temporary zvinobva ravharwa. Kana communication yapera, that port, temporary port, gets closed, it might get assigned to another application on the system. All right, connection establishment. I think one of the roles played by the transport layer when you begin session establishment and termination. Session establishment, let's call it connection establishment, is also known as the three-way handshake. Three-way handshake. 3 steps basically. Step number 1, initiating client requests a client to save a communication. It sends known as a sync, right? Then this is the client. Then the server sends in a sync acknowledgement. The server acknowledges the clients to save a communication session and requests server to client communication. The initiating client acknowledges. Then client acknowledges. Right. Slide ready, it sort of complicates Chirungu. But basically what is happening with TCP connection establishment, we have the client sending the sync. The sync basically is a message which says, I want to establish a connection. So you send a message to this one saying, I want to establish a connection with you. Then this one responds with the sync acknowledgement saying, I've received your request and I'm also wanting to establish a connection with you, and I'm ready to establish a connection with you, basically. Then this one responds, okay, establish a connection, so let's work out a connection so that we can communicate. Basically, in connection establishment, an exchange of sync and acknowledgement messages, synchronize and acknowledgement messages, so that a session is established. Now, with TCP, this is the first process that happens. Establishing a connection. Connection-oriented protocol, TCP. But it's a connection-oriented protocol, because there's actually a discussion in which we want to start sending information. Before information actually sendwa, there is a connection which is established. Though in offering reliability for protocol TCP. Then kana communication yapera. We now have termination. So here, this is connection establishment. Kana yapera, we also have termination. Communication yapera. With UDP, we do not have this. There is no connection establishment. Information inotongosendwa from the get-go. The message inongosendwa from the get-go. With TCP, information sendwa tinotanga establish a connection so that tive reliability. Connection ikanzi haipo, we don't send anything. TCP ibhazi rinongosumuka kuenda, even usuzoti rwizi rwakazara here kana kuti rwakazara, basically. Right, session termination. After we've completed communication, we have session termination. And how does it happen? The device which is responsible for terminating sender fin. It should be finish, short for finish, I think so. Sender fin basically saying, and then I've completed whatever I wanted to send, communication, I'm done. Then this one receives and sends an acknowledgement. I've received your fin, I'm acknowledging Kutindai receiver. Then I'm also ending the session. It also sends its own fin message. Then this one acknowledges fin yako, I've received it. Therefore, let's end this communication. This is basically how a connection is terminated. There's actually an exchange of messages to terminate a session. Right. So, like I said, with TCP, we have this process, a three-way handshake. This one is also known as the four-way. Is it a handshake? I think it's a four-way termination. Four-way termination. When we want to close a session. Right. TCP three-way handshake analysis. The functions of the three-way handshake. One, it establishes that the destination device is present on the network. It verifies that the destination device has an active service and is accepting requests on the destination port number. So as long as personal termination, it means that session is open. It can accept any services. It can accept any applications. Significance of the three-way handshake. It informs the destination device that the source client intends to establish a connection. Okay, we've established that. After the communication is completed, the sessions are closed, the connection is terminated, the connection and session mechanisms enable TCP reliability functions. I think we've gone through this. Continuation of the analysis, we have control flags, which are used in exchange messages during either the establishment of the connection or the termination of the connection. If we go back a little bit, even though header, I think this one is the TCP, not I think, I know this is the TCP header. How do you know? Dorima fields are wonder. I think if memory serves me right, this one, or let me say, could TCP, which one goes? Could UDP, this one goes, I go UDP. Control bits goes, reserved, header length, checksum, I think agent goes, there should be 5, 1, 2, 3, I think reserved goes as well, 1, 2, 3, 4, window. Do we have window by UDP? Flow control, I think this one also goes. Let's see, 1, 2, 3, 4, which is the fifth one. Checksum, 1, 2, 3, 4. Let's leave this one. Let me confirm. These are the kind of stuff you need to know. The TCP header, like I say, information in the TCP header which is not available to UDP header, like I say. Let me just check and confirm before we continue. I think very important. Panama is something. Chichi sipapo. Panaon atina window by UDP. Okay. Let me confirm. That's what I thought as well. Window is used for flow control. So the fifth one is application. So actually four fields. Okay, 5 near data. Right. It also makes it easier to know what every field does. If you know what every field does, it helps you know TCP in my fields, I gotta say, UDP in my fields, I gotta say. If you know sequence number, this one is used for reliability issue. So that to share sequence, we can send for retransmission, we can resend information for retransmission. Therefore, by UDP is simple because we don't have that reliability. Acknowledgement, the reliability as well. Acknowledging could it receive something. Therefore, no need for that. Reliability per flow control. UDP, it doesn't have that. My control bits are session establishment, connection establishment. UDP Atina, they are not there as well. These ones were just reserved. They are not there UDP because we don't reserve anything. The goal, they're going to have less overhead. Agent also removed, less overhead. Then we're only left with the source, destination, header length, and the checksum. This one is also removed. Just around a 4i, former fields. Very important, this one. Knowing fields MTCP header, TCP, UDP header as well. Right, going to 1 minute. Let me just go through quick. The control bits with the agent URG, which is used to point if we have agent data. Kana data remunomri agent, then the control bit, yepa agent, data is agent basically. Then we have acknowledge, we know this one. To acknowledge information, receipt of information. Then we have the push function, which is used usually for applications. There are some applications and not data as soon as it is received, it gets pushed to the application layer. I think we'll later about this. So data these control bits being highlighted, the push function. Data as soon as it is received, carried into the upper layer, which is the application layer. Right. I don't think I'll have enough time to finish PANAP. So another session. Last one.